All right, this video should help you work on how to solve an equation with variables on both sides. So figuring out what does that variable equal to make the equation true. Now make sure you have something to write with and something to write on, so pencil and paper, so we can be working it out, balancing it, all that good stuff that I'll explain, don't worry. So the first option for how to do it is to guess and check, meaning we just pick a number for the variable and see if it works. Now, it can work, it's just not super efficient because it can take us a little while and we don't know how big the number is, whether it's positive or negative, or whether it's even a whole number. So I would recommend using the strategy of isolating the variable. So when we do that, when we isolate the variable, meaning getting it by itself, we want to make sure that we are keeping the equation balanced, meaning if we do it to one side, we do it to the other. I can't just take away or add something to one side because then it'll get all lopsided. So we need to make sure we do it to both sides. We need to use the inverse operation, meaning the opposite operation. So adding, subtracting, those are inverse. Multiplying and dividing, those are inverse of each other. And then at the end, checking our answer. Yes, it takes more time, but the nice thing with math is we can know whether or not we have the right answer. So we'll practice doing that as well. All right, I'll show you the example. I think that will be the easiest. So first equation we're going to practice with is 3x equals x plus 8. So go ahead, write that down and do this with me. I'll walk you through this one. I'll have you try some parts of the next one by yourself, and then I'll have you try the last one all by yourself to see how it goes. So we have this equation. X is on both sides. What could x equal? Well, I want to get x by itself. So let's think about, we have these two sides. I want to get this x combined with those x's. So I want to take it away from here and put it over there. Now, it doesn't really matter which way we go. I could take it from here and put it over there. But you'll start to see that, if I have another term, I want to get it away from that term, things like that. So here I have a positive 1x because if there's nothing there, it's a positive 1. So I'm going to subtract the x. If I do it to that side, I need to do it to that side. So I have 2x left on this side. This went away. I have 8 left on this side. All right, so now 2 times x. So I want to divide by 2 to do the inverse operation. Divide by 2 on this side. 2 divided by 2 is just 1, so I just have 1x left. X divided by 2, or 8 divided by 2, excuse me, equals 4. So I think my x is equal to 4, but let's see. Let's put it in and try it. So 3 times 4 hopefully will equal 4 plus 8. 3 times 4 is 12. 4 plus 8 is 12. 12 equals 12. Good to go. If I got something like 10 equals 8 or just anything that weren't equal, then I would know it didn't work. And I'd have to try it again. All right, this one I'm going to have you do a little bit more on your own. So if I have 37 minus 5x equals 3x plus 13. So I like to draw a line to sort of split up the two sides to make it really clear. Make sure you write that down and are trying it out, not just watching. We want to engage our brains and really do it together. All right, so think about which term should I move first? Hopefully you got it. It doesn't matter. We could really move any of the terms anywhere as long as we're using the inverse operation. Now, I think I usually like to start with my variables, so that's what I'm going to do. In this case, I'm going to move my 5x over to be with my 3x. So, do I want to add or subtract the 5x? Hopefully you chose right that we want to add the 5x because it's a minus 5x. So I want to do the inverse or opposite operation. So minus 5x plus 5x just turns into 0. So I'm left with 37. 3x plus 5x is 8x plus 13 over here. Now, I need to deal with that 13. So if I moved the 37, I would have nothing left on this side, and that isn't going to help me out. So I need to put the number on the opposite side of my variable. So I moved my 13. Am I going to add or subtract it? Hopefully you chose subtracting because it's the opposite of adding it. Minus 13. So then, because if we did plus, I would still have 26 on this side, and I get 50 on that side, and suddenly neither one went away, and I need one of them to go away. So that will go away since I'm subtracting. 8x, I get 24 on this side. Now I have 8 times x, so I'm going to divide by 8, divide by 8. 3, I think, is equal to x, but let's check. So if I have 37 minus 5 times 3 equals 3 times 3 plus 13. So 5 times 3 is 15. I want to do that first because it's multiplying before I subtract. I end up with 22 on that side. Here I get 9 plus 13. So I get 22 on that side. Both sides are 22. Good to go. So my x does equal to 3. Whatever my variable is. It could be m, n, y, whatever. Sorry if my pen gets a little funny. All right, last one I'm going to have you try. So we have 20 minus 7x equals 6x minus 6. Go ahead and give that one a try. See how it goes. Did you get it? Hopefully so. But I'll show you either to reinforce what you did or to maybe catch where you might have gone wrong. So I'm going to add 7x to both sides. So that will go away. I'll be left with 20. 13x over here minus 6. Add on 6 because it's the opposite. That goes away. So I have 26 equals 13x. Divide by 13. So 2 equals x. Now hopefully you even checked your answer to say, aha, I can know whether I got it right. 20 minus 7 times 2 equals 6 times 2 minus 6. There goes my pen again. 7 times 2 is 14. So I get 20 minus 14. 6 times 2 is 12 minus 6. So I get 6 equals 6, which confirms that yes, indeed, my answer is 2. Now, if you need a slower explanation, more examples, more sort of reasoning why, that is what I am here for. Just let me know. Good luck.